Hi guys, today we're working on simplifying radicals, especially the square root of numbers. And this is technically called our objective 4.1, and specifically 4.1a for square roots, but we're doing this now because this is a good place for it. So we'll come across a problem like this. We've seen things like this before, actually, we just haven't known about them. So you'll come across a problem like this when you're asked a question like graph y equals 3x squared plus 6x minus 8 and find the roots. So we are okay with finding the vertex, and then when we go to find the roots, we can use the quadratic formula or we can graph. I'm going to use the quadratic formula just for the sake of making sure we just practice that one more time. So my first step is to write down the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a, and then we know we've got our a, our b, so a is 3, b is 6, and c is negative 8. We've got our a, we've got our b, and we've got our c. So we're going to substitute in, and we're going to do this process just like we always have. So we get negative 6 plus or minus the square root of b squared is 6 squared minus 4 times a, which is 3, times c, which is negative 8, all divided by 2 times our a. We can do some simplifying. We're going to get negative 6 plus or minus the square root. Okay, so then 6 squared is going to be 36 minus 4 times 3 times negative 8. So do this in the calculator, and I get 132, all divided by 6. So this is the part in the past that we've done, and we just haven't done the other part that really is more essential. So when we look at just the square root of 132, we know we can approximate that to a decimal. So I'm going to plug this in my calculator, and I get 11.4891, and it keeps going for a while, and really because it's not a perfect square, aka there's no number that multiplies by itself that's a whole number to be 132, we get this decimal, and we do not like this as mathematicians. Instead, there's a better way to approximate this. So instead of finishing the rest of the quadratic formula for this right now, the only thing we're going to do today is figure out how to simplify this. That way we can come back to this part later. So this is just like getting a setup of where we could possibly see something like this. So let's look at the square root of 132. So the square root of 132, well, again, it's not a nice whole number, but we can write it exactly without this approximation thing that we like, because we do not like approximation. We know that 132, remembering from your factor tree days, is an even number, so we're going to divide it by 2 first. So we're going to get, the remainder is 66. I know that 2 is a prime number. I can't break that down any further other than 2 and 1, so we're just going to leave it as 2. 66 is still even, so we're going to divide this by 2 as well. And then we're left over with, I think, 33. Let's just make sure. Yep, 33. And then 33 is not even, but it is divisible by 3. I'm pretty sure. So let's check. Divided by 3, I get 11. So 3 and 11. So to simplify this, I can rewrite the square root of 132 as 2 times 2 times 3 times 11, because 2 times 2 times 3 times 11 is going to give us 132. Alright, so the next step is this. Circle the numbers that you have pairs of them. 3 doesn't have a pair, 11 doesn't have a pair, but there is a pair of 2's. Because we're doing a square root, which has an invisible 2, and we'll talk more about that later, then we're going to take pairs of them and bring them to the outside. So when you have the pair, you bring one of those numbers to the outside, you leave the other numbers on the inside, and then you simplify as you can. So we can simplify 3 times 11 is 33. So the simplified exact form of the square root of 132 is 2 square root of 33. And you can check this in your calculator. Take the square root of 132, see what you get, your approximation over here. If you type in 2 square roots of 33, you should get the same decimal approximation if you do this correct. So this is the most simplified form of this radical. And we like this as mathematicians for a couple reasons, which we'll get into the future. The only thing I'll say today is this. This is a lot easier to write than this. There's 3 numbers here, but this has way more numbers and it keeps on going. And this is an exact, precise answer. So this is the most simplified form of a radical for square roots that you're going to have to deal with. And this is it. We don't have to do the whole quadratic formula for this. We just have to take numbers that are square roots and simplify them further. And again, this was just an example of a time that you might see this, and we'll definitely come back to this in the future as a review of both taking the square roots of radicals and as a review quadratic formula. Okay, so let's do a couple more of the radicals under our belts. So, square root of 200. Unless you are able to precisely do the prime factorization, which is what this thing is called the prime factorization of your number on the inside, you should definitely make yourself a little tree each time. So for 200, I'm going to
I know that 200 is 2 and 100. I know that 100 is 2 and 50. I know that 50 is 2 and 25. And I know that 25 is 5 and 5. So, I'm going to go ahead and write my 2 times 2 times 2 times 5 times 5, just the end of my radical, I guess my factor tree here. So square root of 200 is the square root of 2 times 2 times 2 times 5 times 5. So I'm going to circle the ones that are pairs. So pair of 2's, pair of 5's. So I'm bringing one of the 2's to the outside, one of the 5's to the outside, and leave a square root of 2 on the inside, and the only thing for me to wrap up is 10 square root of 2. Alright, so our second example. Square root of 72. We know that we can break 72 down using a factor tree into 2 and 36, which we know that 36 is 2 and 18, and 18 is 2 and 9 is 3 and 3. So we're going to rewrite square root of 72 is the same as a square root of 2 times 2 times 2 times 3 times 3. And again, we're going to circle the pairs. Circle the pair, circle the pair. Bring one of the numbers in the pair to the outside, so one of the 2's and one of the 3's, and make it multiplication between them. Square root, leave that 2 on the inside. All we have to simplify is just the stuff on the outside. We get 2 times 3, which is the same as 6, leaving the square root of 2. So the square root of 72 is equivalent to 6 square root of 2, no messy decimals. We don't like Radical 55, square root of 55. So 55 is kind of tricky, and that it can only be broken down into 5 and 11, and that's it. That's the only thing that can break it down. So if we were to try to do this process, we get the square root of 55 is 5 times 11, and there's no pairs of numbers. 5 and 11 are both prime. You can't break 5 any further. You can't break 11 any further. So because we cannot break this down any further, we're just going to leave it as a square root of 55. That's fully simplified, unfortunately. We can't do anything else to it. Alright, so here's the only time you can do this. If you cannot break either of these down any further, so you've gone through and you've checked every possible combination of numbers that would multiply to be that number, that's the only way, if you don't have any pairs in here, that you can just leave it. Otherwise, you've got to go through this process of breaking down this factor tree and go for it. Alright guys, I'll have a practice worksheet. We'll do another couple of these problems in a couple minutes. Make sure you have these notes first, and then we will get going. Alright folks, thanks a lot. I'll see you next time.